Let's talk about research methods and how researchers establish that one variable causes a change in another variable. Causality is at the heart of science. We want to know what causes outcomes, what causes cancer, what can increase memory, what can reduce pain, what can improve mood. How do we establish that an X can cause an outcome and why? If you want to know for sure what causes an outcome, the true experiment is the only way to do it. In a true experiment, a variable is manipulated and you observe to see if an outcome changes in another variable. So the IV is the X, the cause, presumably, and the DV is the Y, the outcome. The best true experiments also have random assignment. That means when you take all the volunteers that have volunteered for your study and you use a flip of the coin or drawing names from a hat to assign them to which experimental condition they will get. That ensures there's no systematic bias in placing people in conditions. A second factor is you try to control all the extraneous variables that might affect the outcome. So true experiments must have really great control over the setting and also use random assignment of participants. If you find two variables are correlated, it's not enough to then conclude that one of them is causing a change in the other. Correlation is not causation. We frequently are misled into believing maybe it does suggest causation, but it never does. News stories frequently say there is a link between two variables and give the impression that one might cause the other. So in this example, it says ADHD, the neurological condition, may be related to sleep problems. So sleeping badly may actually predict that you would have more ADHD symptoms. But is the relationship causal? Is the bad sleep causing the ADHD? Not likely. It's more likely that both conditions are related to a third variable, such as a biological neurological condition that's both contributing to your sleep patterns and also your attention symptoms. What is a quasi-experiment? Well, it's a study where you don't manipulate a variable, but you compare different kinds of people. So in the news article, it would be people with ADHD will be compared to people without ADHD in terms of their sleeping habits and other variables. So people come to the study with that characteristic that you're going to compare. So studies of men versus women, different age groups, smokers versus non-smokers, these are all examples of quasi-experiments. And you cannot conclude causation because you have not manipulated that variable. Because many of the variables that we want to study in human research studies are of this sort that you cannot manipulate, it makes studies of humans quite difficult. And also I think the challenge is something that many psychologists truly enjoy. How can I get at that and study that phenomenon when I know that I can't manipulate that variable? It is often the case that when we can manipulate the variable, it's unethical to do so. So for example, imagine that you believe that potato chips might be a bad thing for us to eat. It might cause negative health outcomes. Well, if we wanted to show that in a true experiment and randomly assign 50 people to eat chips a lot and 50 people not to eat any chips, and then compare the health outcomes after a year, we are setting people up who eat chips to actually get sick. That's unethical. In society, sometimes even when we do not have quintessential confirmatory evidence of a causal relationship, we may conclude that there probably is one anyway. This is when we use converging evidence. So there's never been a true experiment with human beings showing that cigarette smoking causes negative adverse health outcomes. There have been correlational studies, many of these, and there have been animal studies in which true experiments were done, and it's been shown that cigarette smoking in animals causes negative health outcomes. but the true experiment in humans is lacking due to the ethical reasons we discussed previously. So today in society, most of us believe most likely that yes, smoking is not good for you. And it's not because there's been true experiments with humans to prove it. It's because of all of the correlational studies and all of the animal experiments. These together with public opinion have convinced us. That's all for now.